Hello everyone and welcome. Today I'm excited to share a personal portfolio and a year in review of 2025. This presentation captures my journey through a year dedicated to three pillars: building, learning, and exploring. My name is Yann Debray, joining you from Boston in the United States. And in my personal and professional life, I identify strongly as a builder and as a thinker, and I'm always seeking to create and understand new things. Through this portfolio, I'll walk you through the projects that I've built and the knowledge that I've gained and new horizons I've explored over the past year. Let's dive in. So in 2025, I've embarked on an adventure of exploration and operating at the vibrant intersection of code, data, and a little bit of philosophy, but that's more on the personal side. My journey, it's including creative vibe coding experiments that I found unexpected and learned a lot of things about market fit. YouTube video series designed to teach machine learning through the lens of sports data. And I also have been diving into technical exploration, developing coding agent, and strengthening my understanding of the Model Context Protocol (MCP). I anchored all of those pursuits in a dedicated program. And grounding a lot of this in existential question about the meaning of agency in the AI age. So this year, this is just like a few metrics here, giving you a sense. So publishing 6 videos on sports analytics and AI, contributing to open source projects and the community, by creating 12 GitHub repos, experimenting with reaching an audience organically with over 8,000, at least 1,300 organic visitors per month, and deepening my understanding of some of the concepts in philosophy, existentialism. Sorry. I'm a big fan of Sartre and AI also, with a few good books that I can recommend in the comment section. So I've also been building a complete MATLAB toolbox from scratch with the help of AI, something that I never thought I would do before. So let's start with the accidental product, the kitchen demo that turned to 1,300 monthly visitors. So this slide is highlighting the resetthezoe.com. It's a website that I've built in August of August of 2025. The origin story begins in Argentine, where I was just shortly after the release of GPT-5, and I wanted to demo coding, vibe coding. So I simply asked my father-in-law that was visiting at the time what website or web app he would like, and he pointed to a recipe book. It was at night. It was around 9 or 10 p.m. and I just created a very simple French recipe website with a single AI prompt in one session, and purchased the domain name on Cloudflare immediately. The real surprise came a few months later, at the end of the year, as I was reflecting on all of this. 4 months later, with absolutely zero marketing or SEO, search engine optimization efforts, the Cloudflare traffic had essentially exploded. As you can see from the graph, it jumped to more than 8,000 organic visitors in the past months alone. So for this, the tech stack was very straightforward. HTML, CSS, and JavaScript. No fancy React. I've been staying away in 2025, at least, from more evolved TypeScript type of apps. So very basic web apps powered by GPT-5 and hosted on Netlify with a Cloudflare domain name registry. So this truly demonstrates how from a simple idea powered by AI now, you can unexpectedly grow into an interesting product and without any active promotion. Now, Ghost Runner. That is another idea, another app, ghostrunners.app, that I had also over the summer, and this I'm naming it like racing my own ghost. So it's the idea of a cycling analytics workflow designed to help riders like myself improve on a bicycle. The core problem was a very common one. I wanted to beat my personal cycling record, but I was lacking real-time analytics to compare current efforts against my previous best on the same routes. So the solution that I thought would be addressing this, it started through a two-part workflow. First, I track my ride. I track your ride is just simply using MATLAB Mobile and recording sensor data like GPS and acceleration with my phone. And this data then was used to visualize the route and animate it, speed colored maps, giving an immediate visual overview of the performance. The second part is where you beat your ghost. Here I compare two rides, the current ride against a previous ghost performance. And then the system is going to classify your movements versus any stops and help diagnose precisely where and why time was lost, providing some insights for improvement. So a key differentiation that I have in mind with this approach in Ghost Runners is the power estimation without needing a power meter. So it's just leveraging a very simple physics-based approach as illustrated in the diagram and analyze the forces like aerodynamics, rolling resistance, inertia, and gravity to just calculate the normalized power, NP, and generate a power duration curve. This was allowing me to do some sophisticated performance analysis without the need for expensive dedicated hardware like a power meter. So by combining the accessible data capture with a simple phone, the clear visualization and advanced physics-based analytics, this project, Ghost Runners, was empowering me as a cyclist to understand and surpass my past performance. So now sports and as a machine learning playground. So this is not just for entertainment. Obviously, like I've been a little more into sports this year, especially the basketball and American football. But it's not just for entertainment, it's an incredible playground for machine learning. So this slide shows how different sports provide intuitive domains for exploring a wide range of core machine learning concepts, from fundamental classification and sophisticated feature engineering, and all the way to robust ranking systems and intricate time series analysis. So let's start with tennis. Here, I focused on predicting the tournament outcome for the French Open at Roland Garros, and this involved a deep dive into feature engineering, identifying crucial player and match statistics, and then building a ensemble model, a boosting tree to make accurate predictions. Now moving on to the NBA, it offered a nice way to visualize team dynamics. So I applied the same ELO rating system that I used for tennis, that is quite famous for chess, to track team performance and strengths over time. And I managed all of this data with automated pipelines. So here, most of the learning was around data engineering and pipelines. And finally, with the NFL, I tackled the challenge of defining and identifying the clutch performance. I'll speak a little bit more about it in a moment. And this involved in-depth agent-driven data analysis to pinpoint and quantify the critical, last moment game-changing moments on the field. That's what clutch means. So predicting the French Open, it was a journey to from 58%, which isn't great, to 76% accuracy, which in sports starts to become slightly more decent. So the spark for this project was quite simple. My wife was watching Roland Garros in the beginning of the summer on TV, and I decided to try and predict the winner. So to do this, I followed a clear methodology. First, for the data, I started with the 2024 ATP match data, focusing specifically on clay because Roland Garros is playing on the clay court, and then extending it to include data from the past 5 years. For the system, I adapted the well-known ELO rating system, typically used in chess for tennis. And the features, they evolved quite significantly. I began with just 2 features, the ELO difference between players, and then expanded it to a comprehensive 11 features, incorporating elements like ATP rank, player age, current form, serve power, etc. Finally, I experimented with several robust models, including decision trees, random forest, gradient boosting, and a simple multi-layer perceptron to find the best predictive performance. You can see the results of this iterative process on the right. The initial model with just 2 features yielded a 58% accuracy, and by enhancing it with 11 features, it saw a substantial bump to 75 accuracy, 75% or 76%. And by extending the data to 5 seasons, that's when the extended model achieved the 76. Based on this analysis, the prediction for the French Open winner was Yannick Sinner, winning with a probability of 63% over Carlos Alcaraz. And you can watch the game if you want to see the outcome of this. The key factors, then that's some of the interesting elements of this analysis, is the feature engineering. The key factors influencing the prediction is where Sinner overall ELO dominance balanced against Alcaraz. So now dissecting the NFL, going from a clutch analysis to a toolbox. So the project Dissecting the NFL explores how clutch play analysis ultimately leads to building a more reusable MATLAB toolbox. So the method starts with leveraging OpenAI Codex in a more hands-off agentic cloud environment, which I used on my phone most of the time, just like in a web browser. And the definition of clutch is very specifically here. It's any moment where the score differential is within 7.5 points, occurring in the final 7.5 minutes of the fourth quarter or overtime. So the analytical pipeline, it involved retrieving 25 seasons of the NFL data and filtering it down to these specific clutch plays, and then computing a TV clutch factor for quarterback. So this was performed with the use of the NFL Data PY Python package. So the initial analysis then inspired me to create a reusable MATLAB NFL toolbox. That was my first experiment in building such a tool, and I was significantly aided by AI. The toolbox acts as a Python bridge to access the comprehensive NFL data through this package that I mentioned from Python, and it provides high-level MATLAB functions like get weekly stats, plot top players for easy analysis and visualization. And it also incorporates environment validation to ensure smooth operation. So the key learnings from this entire process is that building a proper MATLAB toolbox, even for personal projects, is an excellent exercise in software engineering discipline. Now, deconstructing music tests with KNN. So today we're going to, in this one here, demystify how music recommenders work using the K-nearest neighbor, or KNN, in a mini Spotify-like setup. So my main goal is to make machine learning algorithms more accessible by relating them to something familiar, that is music taste. So let's look at the demo simple 3 steps workflow. First, you search for a song. Then using the Spotify API, this extracts the 7-dimensional audio features for that song. And think of those features as a unique numerical footprint, capturing aspects like danceability, energy, and valence. And finally, those features are being used to find similar songs by identifying its k nearest neighbors. Specifically, that was using cosine distance, cosine similarities. Now, let's turn to the diagram to visually understand KNN. Imagine our songs are points in a space defined by those audio features. The bright orange dot represents our query song, and KNN works by looking for the k closest songs around it. In this example, with k equals 5, I identify the 5 nearest neighbors, which are the green dots enclosed by the dashed circle. These green dots, through a majority vote or simple aggregation, are then identified as our similar songs. Now, looking at the details for KNN, at its core, it calculates the distance from our query song to every other song in our library. It then selects the k songs with the smallest distance, and for our music feature, cosine distance is a particularly good choice because it measures the angle between vectors. So effectively, it's capturing similarity in a high-dimensional audio data better than a straight line Euclidean distance. And the beauty of KNN is that it's intuitive and versatile. It's requiring no explicit training time, but however it does have its challenge. It's struggling with the curse of dimensionality in a very high dimensional space, since it's memory heavy, and it's potentially having costly queries as the dataset is growing. Now, this slide is illustrating the rapid evolution of the workflow with AI, transitioning from merely AI-assisted coding to a powerful AI-led analysis. In stage 1, early days, I experimented with VS Code integrations, where AI was a direct coding assistant, and this involved a tight feedback loop, particularly for developing HTML and JavaScript application. And I would provide the prompt, the AI would generate the code, I'd preview it, and then we would iterate. The AI was explicitly assisted my coding. But quickly, I moved to coding agents. This is much more hands-off, exemplified by its application in complex tasks like the NFL clutch play analysis. Here, the AI isn't just assisting, it does the coding, while I supervise. My role shifts significantly. I describe the overall goal, I let the AI agent work autonomously to achieve it, and then critically review the final results. And along the way, I also validate that it stays on track. So the progression from AI assists my coding to AI does the coding while I supervise is truly happening very fast and much faster than I expected, making a very significant and exciting shift in how I now leverage artificial intelligence. So today I want to share some reflections on technical patterns that truly worked well for me over the course of the year and across various projects. So first, I learned the surprising value of spontaneous creation. The example of the recipe website that I initially built as a simple demo for a family member unexpectedly evolved into a real traffic generating product. So this experience highlighted how sometimes the most impactful and valuable projects can emerge from the most casual beginnings. Moving on, I found that leveraging intuitive and data rich environment was key for education. So sports data from tennis, the NBA, the NFL provided excellent context for teaching and effectively applying complex machine learning concepts. Their inherent familiarity and rich datasets made abstract ideas much more tangible and engaging. Another powerful pattern I successfully employed was bridging different tools. So the cycling and NFL projects, for instance, they perfectly demonstrate how to combine the strengths of MATLAB for computation and visualization with the Python very large ecosystem. And this allowed me to create clean and powerful workflows for deep analysis. And finally, for a common challenge, data dashboards requiring periodic updates without the need for a dedicated server. For this, I discovered that the pattern of using scheduled GitHub actions alongside GitHub pages offers a very complete and wonderfully robust solution. So it provides an efficient and cost-effective way to keep information fresh and accessible. And this example underscored the different ways I found technical solutions that not only solved immediate problems, but also provided broader insights into effective development and teaching. Now, what would I do differently? Reflecting on past projects, there are three main things that I'd definitely do differently moving forward. Valuable lessons learned that truly shaped my approach and potential future projects. So finally, first, I'd make a conscious point to document more as I go. Crucial projects with their unique context and valuable learnings truly benefit from very thoroughly writing up, captured in real time. This ensures that nothing important is lost and forgotten down the line. Second, a powerful takeaway was the importance of shipping faster and polishing later. The unexpected success of the recipe site perfectly illustrates this. So it thrived precisely because I launched it quickly without getting bogged down in overthinking every single detail. It's a clear lesson in prioritizing immediate action over endless deliberation. So finally, I'd actively seek to cross-pollinate ideas and patterns more aggressively. For instance, the robust analytical patterns that I developed for our sports data could be abstracted into reusable libraries much sooner. So this would have dramatically increased efficiency and amplified my impact across a wider range of projects and leveraging more of the efforts broadly. So these are the key insights and adjustments that I'm carrying forward into 2026. Thank you for listening and sticking around, and I hope you learned a lot as I did. And happy 2026.